What's up, Seahawks? It's Miss Adams, and in this video, we're going to talk about categorical data. So first, what are data? Data are values along with their context. So we really need to know, what are these numbers, variables, categories, what do they represent? That's the context piece. And data can be numbers or it can be labels. And the who, what, when, where, why, and how of data. So in order to determine the context, we need to consider the W's and H. So who would be the cases about whom the data was collected. If we're referring to people, we're talking about people, we sometimes call them respondents, subjects, or participants. And the who doesn't always mean that we are talking about people, so it can be other things as well. What and in what units, the variables recorded about each individual. So there's different types of variables. We could have categorical or quantitative. The when is when was this data collected, not when was the data used. Okay, so you want to make sure that you have data that was recently collected, not from 1980, and then you're going to do statistics on it now because it probably doesn't apply. Where was the data collected? Why helps us determine if the data should be treated as categorical or quantitative. And how was the data collected? And we don't always have the answers to all of these pieces, but the more of them that we have, the better we have of making a case for what the context is. Okay, two types of variables. A qualitative variable is used to answer questions about how cases fall into categories. So may be comprised of word labels or numbers as labels. So some examples of qualitative categories or variables would be color, gender, type, and zip code. And zip code is one of those ones where we're using a number as a category. And then quantitative variable is used to answer questions about quantity of what is being measured. It's comprised of numerical values. So some examples would be height, weight, dollar amount, size, test score. All right, this example, I want you to kind of pause and answer this. All right, are the numbers 17, 21, 44, and 76 data? So the answer is no, because there is no context. Okay, another example. A report on the Boston Marathon listed each runner's gender, age, or gender, country, county. Okay, another example. A report on the Boston Marathon listed each runner's gender, county, age, and time. Identify the following. So, who would be the Boston Marathon runners? What would be the variables that I collected, the gender, county, age, and time? When? Well, that was not specified. Where was in Boston. Why was the race results reporting, so we could report out. And how, it wasn't specified, but we can assume some of that was maybe from registration info. And then what are our categorical variables and what are our quantitative variables? So the categorical variables would be the gender and the county. And the quantitative variables would be their age in years and the time in hours, minutes, and seconds. And when you're talking about quantitative variables, you want to make sure that you give the units. All right, so the number one rule for data analysis is make a picture, make a picture, make a picture. Okay, if you can draw a picture to summarize your data, it's going to make things a lot clearer, and it's also going to make it easier for other people to interpret what you're trying to have them interpret. All right, a frequency table. We use this to organize counts by recording the total and the category names. So we're going to find the proportion, percent, frequency, and relative frequency of sophomores. So I have grade 10, 11, and 12, and it tells me the total. So for the proportion, I have 534 sophomores, and I need to figure out how many total students this is out of. So 534 out of, if I add up 10th, 11th, and 12th grade, I get 1,601. So there's my proportion, or I could write it as a decimal. So that'd be 0.3335. And then in percent form would be 33.35%. Okay, remember you just moved the decimal 2 places to the right. or multiply by 100. Frequency is just basically the counts. How many sophomores do you have? So 534 sophomores, and you want to keep it in context. And then relative frequency is the count as a percentage. So I changed it to percent, 33.35% sophomores. All right, categorical distributions. So some different ways that you can make a picture for your categorical distributions would be a bar chart or a relative frequency bar chart. So the difference between a regular bar chart and a relative frequency bar chart is just one has relative frequency, so using the percentages, and one has counts. Okay, and they're always going to have spaces between the bars. All right, a pie chart is going to be used for if you're dealing with percentages. And you want to always make sure that you have labels and percents. Okay, you're often going to have to make a key or use different colors, but it's very important, even on the AP test, if you do draw a picture, any graph later on when we learn different topics, and you're still drawing pictures to explain your ideas, you want to make sure you always label all the pieces. All right, a contingency table or a two-way table. So in here we have grade and gender. So identify the row variable, column variable, total, which we call N, number of cells, and where the totals are. So our row variables are gender, male and female. Our column variables are grade level, freshman, sophomore, junior, senior. Our total N would be in that bottom right corner, so right in here. And the number of cells would be 8. Okay, you do not count the little boxes that make up the total columns or the margins. Okay, and then the totals are found in the margins, okay, which are the outside, all the way to the right and all the way on the bottom. All right, let's look at an example using those two-way tables. So we have hospital choice and survival outcome. What percent of people died? So first I'm going to fill in my margin. So I'm going to add across and add down. So 79 total people died, 2,821 total people survived, 2,100 total people were from hospital A, and 800 people total were from hospital B. And if I add the totals, I get 2,900 total. This next question, it says, what percent of people died? So percent died, and I'm going to write it, that's probability notation. We'll talk more about that later on, but the percent that died is going to be how many total died, which is 79, out of the grand total, which is N. So N, again, is going to be in that bottom right corner. And if I change that to a decimal, I get 0.0272, or as a percent, it'd be 2.72% died. And I'm putting it back in context. All right, what percent of people were from hospital A? So I'm going to look at the total from hospital A out of the grand total. So 2,100 out of 2,900 percent, I get 72.41% from hospital A. Now this next one is a little bit more complicated. Among those that survived, what percent of patients were from hospital B? So the notation for this is going to be the probability that they're from B given, so that little bar is saying given, they survived. So from hospital B, given they survived. So I have 784 survivors that were from hospital B. Out of the total that survived was 2,821. And then I can change that into a percentage. So 27.79% of those that survived came from hospital B. All right, two types of distributions for categorical variables. So we have marginal distributions, we're going to convert the totals into percentages. Okay, so find the marginal distribution for hair color. So for brown, I'm looking in the margins, so only in the totals area. I had 46 total brown out of 136. Okay, so that'd be 33.82%. Blonde, I had 59 total out of 136, so 43.38%. Black, I had 22 total out of 136, just 16.18%. And red, I had 9 total out of 136, which is 6.62%. Then find the marginal distributions for gender. So for male, I had 63 total males out of 136 total people in this group. So 46.32%. Females, I had 73 total out of 136, which is 53.68%. Okay, so marginal distributions, you're looking in the margins. Okay, if we wanted, we can make a picture. So at a bar chart, I just did it by color, and I matched up the percentage as close as I could on the graph. Kind of a rough sketch. Then by gender. And there's something kind of funny going on here. Okay, hopefully you notice it. I just want you to maybe take note, put a little caution, and write a little blurb if you notice it. If not, we'll point that out when we get into class. So something to talk about. So now let's take a look at conditional distributions. So we have that same two-way table, hair color versus gender, and we want to find the conditional distribution for hair color variable. So we have brown, blonde, black, and red, and we're going to do this for both male and female. So I'm going to organize this up a little. So for males and for females. All right, for brown and males. So I have 26 males with brown hair. Out of, my hair color is the variable, out of 46 total with that hair color. So, and I could get a percentage. For blonde, I have 24 males with blonde hair out of 59 total blondes. Black, I have 10 males with black hair out of 22 total people with black hair. In red, I have 3 males with red hair out of 9 total redheads. For females, I have 20 females with brown hair out of 46 total. For blonde, I have 35 out of 59 blondes. I have 12 with black hair out of 22. And red, I have 6 with red hair out of 9. So then I can get all of those conditional distributions. All right, so now I'm going to do the same thing for the gender variable. So I'm going to have to do this for each color now. So I have 26 males with brown hair out of 63 total males. And I have 20 females with brown hair out of 70 total females. So for males, it's always going to be out of 63. For females, it's always going to be out of 73. I have blondes, I have 24 out of 63 for males. For females, I have 35 out of 73. Black, I have 10 out of 63 for males and 12 out of 73 for females. Red, I have 3 out of 63 for males and 6 out of 73 for females. All right. Represented visually, you might want to use a segmented or stacked bar graph. So these work really well. Each bar represents 100%. The values of the variables are on the x-axis, and the bars are segmented into parts of each value. So we did this for both the variables, male and female, and the different hair colors. And so you're going to want to use different colors or different patterns, okay? And you want to make sure that you have these all labeled appropriately. All right, that's it.